Hi guys, welcome back to the channel. Jag here, and in today's class we're going to continue with our Math 9 content, and the topic today is going to be on direct variation. So with that, let's get started. We're going to try some of the questions from the textbook here. Alright, so first off, what we're going to go through is the constant of variation. Okay, and what does that mean? Okay, so I'm going to write it on here. So constant of variation. Okay, the constant of variation is basically a constant that is in this direct relationship. Okay, in a direct variation, if you were to graph out the actual equation, it has to start at the origin. So it has to start at 0, 0. Okay, and it's going to be just a straight line. Okay, let's try determining, the constant of variation for each of these direct variations. So the distance, so let's try an example. Alright, so this is the distance that is traveled by a bus, varies directly with time. The bus travels at 300, or it travels 300 kilometers in 3.5 hours. So let me write that down. Okay, again, make sure you do note down in terms of the units here. Okay, and when we're finding the constant of variation, okay, we're just going to divide the two numbers together. So the constant of variation is represented by k. So we're going to do 300, okay, divided by 3.5. And you see that we're getting 85.7. Okay, this is, let me write the units. This is kilometers per hour. Okay, and so basically, this is how I would actually determine the constant of variation. If I did have to write the actual equation, let me write it right here. So the equation is basically the distance is varying directly with the time. Okay, so we'll use d for the distance. So d equals 85.7 times the time. So we could put times t. So just like this. Okay, so I notice in the direct variation, if the value for t is 0, the distance would also be equal to 0. Okay, and that's how you know that the direct variation is actually starting at the origin. Okay, are there any questions there? Okay, good. Let's try one more example here. Okay, for the constant of variation, so I'm going to just take this off. So I'm going to read it out loud. Okay, so the total cost varies directly with the number of books bought. Okay, so I'm buying 5 books, and that costs $35. So this is something just really simple here. Okay, just so we know how to calculate the constant of variation, you're going to put k equals, okay, whenever you have something like this and you're dividing the numbers, the cost should always be on the top. Okay, so we're going to do 35 divided by 5, okay, which is equal to 7. All right, so again, make sure you do put the units, okay, for the constant variation here. This is $7 per book. Okay, I'm putting the units so everyone can see, okay, where the number is coming from, and this way you know that the cost has to go on the top. Okay, and then you just divide the two numbers. Okay, say I'm looking for the equation here in this example. Okay, so again, the total cost, so we could just use the value c equals 7. Okay, and it's varying with the number of books that I'm buying, so I could do like 7n. Okay, so this is my equation where c is the cost, okay, and then n represents the number of books, okay, that you're going to buy. All right, so that's how you calculate the constant of variation. So let's move on to the next example, okay, and we're going to try making a table as well as just graphing it out. All right, so I'm going to just take this off. Okay, and we'll try just like a simple example here. Okay, so let's try this one. Okay, so it says Pasant's pay varies directly with time in hours that she works, and she's earning $8 per hour. Okay, so let's put that. Okay, she's making $8 per hour. Okay, you can choose the appropriate letters for the variables. So actually it doesn't matter which letters you want to use. Okay, I always use something that kind of relates to what the question is talking about. So make a table of values showing percents pay for 0 hours, 1 hour, 2 hours, 3 hours. Okay, so we're gonna kind of like just make a table on this side here, like this. Okay, and let's use H here. So H represents the number of hours, okay, that she's working. Okay, and then P represents her pay. All right. So it says to use 0 to 3 hours here. Okay. So if she doesn't work at all, then she's not making any money. So I notice right away that this is a direct variation because I'm starting at the value of 0, 0, okay, or the origin. If she works for 1 hour, she's going to make $8, okay? And then if she works for 2 hours, she's making $16. And just like that, if she's working again for 3 hours, she's going to make $24. Okay, and then you can see so on and so forth, okay? This is a direct variation. The number of hours I work and the pay that I'm getting, both of these variables are directly related to each other. Okay, say I need to write an equation, okay? It says to graph the relationship, but also write the equation in the form of y equals kx, okay? In this case, I want to just write it like this. So pay equals, my constant of variation is $8 here because that's how much she's making per hour. So 8 times H, okay, is going to be the pay rate, right? So say I need to calculate my pay and she's working, or not my pay, okay, percents pay. So say she works for 10 hours, right? And I'm just using this equation to calculate how much she's making. So you can directly see I'm doing 8 times H. Okay? Or just like this, okay? 8 times 10. And her pay is going to be $80, okay? If she works for 10 hours. Okay, so the direct variation is very simple in terms of its equation and what I need to calculate. Okay, now say I need to just graph this out. So we'll do like a really quick sketch here. Okay, make sure everyone can see that. All right. And on the bottom, what you're going to do is just put the number of hours. So start from 0 here. We'll just do it up to 3, okay, because that's what the question is asking here. Okay, and on the side is going to be the pay, okay, that she's making. So even with the pay rate on the y-axis, okay, you could just take a scale just going up. So we're just going to go up by 8 here, okay? So 24, 32, okay, and 40, and so on and so forth, okay, because we're just going up by 8. Then you're going to plot each of these coordinates, okay, onto the graph. So I have 0, 0, and then 1 and 8, okay, 2 and 16, 3 and 24. So as you're graphing this, okay, make sure you are using a graph paper at home when you're trying this question out. Okay, and at the same time, when I'm actually putting these points together, okay, I want to make sure I'm using a ruler. Okay, does everyone see that? Okay, so maybe let's put a title here. Okay, so we'll put percents pay. Okay, and that's basically how much she is making. Okay, and I can see it's a direct variation. It's starting at 0, 0. Okay, and like I said, it's basically a linear relationship and it's going to be a straight line, okay, that is increasing. Are there any questions there? Okay, so that looks good. Let's try one last example here. Okay, so I'm going to take this off. Okay, and again, this is an example for direct variation. Okay, so I'm going to read the question out loud. Okay, so A, parking garage charges $2.75 for parking. And we're going to use our graph here. So we do have to graph this out, but let's make the table first. Okay, so I'm going to put $2.75. Sorry, let's put per hour. Okay, per hour that you are parking. Okay, so maybe it's like a downtown parking garage. Okay, usually the pay rate is much more than this. Okay, $2.75 is kind of cheap. All right, so let's do our table before we graph it out. And then we'll also come up with the equation as well. Okay, so let's do again H. And I'm going to use C, okay? C for the cost. So maybe let's use N. Okay, because C and N is used quite often, okay, when you're coming up with these equations. Alright, so let's do 0. Let's do the same thing, 0 to like maybe 3, okay? And let's come up with our equation first. So this is the cost. My constant of variation here is 2.75 because this is per hour. So it's going to be 2.75 times N. So I'm just going to box our equation here. Okay, so it looks like this. Alright, and now all we're doing is just plugging in our values, okay, into our calculator. So if you just plug in 0 here, for N, it's 2.75 times 0, which is just equal to 0, okay? So say I plug in N equals 1, it's going to be 2.75 times 1, which is equal to 2.75. Does everyone see that? Okay, then you're going to do 2.75 times 2, which is 550, okay? And then 2.75 times 3, which is 8.25. Okay, make sure you, because this is like the cost, I always make sure I'm rounding it to 2 decimal places. Okay, I have the dollars and then the cents. Okay, so this is basically our table here. Okay, the question is asking us to illustrate this relationship graphically, and you can represent it with an equation like we just did. So let's maybe try a quick sketch of our graph here. Okay, so say it's like this. All right, and again on the bottom I'm going to put the number of hours. Okay, and we'll just go up to 3 here, and again I can just continue this pattern, okay, for maybe a couple more hours to make my graph more accurate, but you don't really need to do that. On the side is going to be the cost. Okay, I can take basically this same scale right here. It looks like we're just increasing by 2.75 each time. So let's write that. So we'll put 2.75, then 5.5, okay, and then 8.25. Okay, does everyone see that? Okay, and all we're doing here is basically just graphing out each of our coordinates to represent this variation graphically. Okay, so I know we started at 0, 0, okay, and then 1 and 2.75, then 2 and 5.50, like this. Okay, and then 3 and 8.25. Anytime you do represent, okay, the direct variation graphically and it's not a straight line, make sure you just go back and check maybe your table as well as your equation. Okay, make sure you wrote it down correctly. So I'm going to just join all these points together like this. Okay, and just make a straight line. Okay, so you can see that this is a linear variation. Okay, I'm gonna put cost. Let's put at a parking. Okay, garage. Okay, make sure you do actually put like their title. Okay, this is the number of hours. Okay, on the bottom. Okay, and on the x-axis, and on the y-axis we could just put the cost. Okay, and the cost is in dollars. All right. So again, when you represent it graphically, make sure you do have a title for your graph, and I have to make sure I label all the axes as well. All right. Okay, so it does say to use your graph to kind of estimate, okay, what the cost will be for 7 hours of parking. Okay, we're just going to, and then it says use your equation to determine the exact cost for 7 hours of parking. Okay, so let's try using our equation here. So I'm going to do 2.75 times 7 hours. Okay, does everyone see that? Okay, and you multiply it, and we're getting $19.25. Okay, and I can see that it is more accurate, okay, if I'm using my equation. I mean, we can always just extend our graph like this. Okay, you can extend your graph like this up to 7 hours. Okay, this is you actually extrapolating and coming up with the value that you would have here for the cost at 7 hours. Okay, what you would do here is basically just extend your line using a ruler, okay? And you can see if you just extend your line like this, I can still kind of estimate what my answer would be at 7 hours. Okay, but one more time, because it's a graphical representation, okay, it won't be very accurate, okay? It's only accurate when you're actually using the equation and just plugging it into your calculator. All right? Okay, so that looks good. And that brings this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone in the next video. Thanks, bye.